Greetings, my statistics friends. Let's take a look at the difference between the binomial PDF and the binomial CDF. The binomial PDF stands for the probability distribution function, and the binomial CDF stands for the cumulative distribution function. The biggest difference between these two things is the binomial PDF is the probability of success on a single trial, and the binomial CDF is the probability for the cumulative probabilities for success on the trial you're talking about and all of those before it. So remember that in a probability distribution, the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus ... plus the probability of all equals 100% or 1. So the binomial PDF, N is number of trials, P is the probability, and R, sometimes we put X, is the place of interest. So binomial PDF of NPR of a single trial, R is the exact number that we're interested in. The binomial CDF NPR is the cumulative of R and less than or equal the number of things that we're interested in. So if we were interested in, let's say, probability 3, binomial PDF of 10 trials with probability whatever that is, let's say 10%, and then R was 3, we would be talking about the probability of exactly here 3. If we're talking about the binomial CDF, then we'd be talking about N would be 10, P in this case would be 10% in this example, and then R would be 3, but we're summing up the probabilities of 0 and 1 and 2 and 3. Let me show that to you on a calculator. So I go to the binomial distribution. So I hit second and then the vars button to get to the blue distribution menu. So second and then vars for the distribution. And the binomial distribution is the bottom. So I scroll all the way down to binomial PDF. And let's say I had 10 trials. And the probability, as I said in this example, was 10%. And I'm interested in the third one. And so I hit paste. So this is binomial PDF, N, probability P, and the number that I'm interested in is 3. And so that tells me 0.057. So that's the probability of exactly 3 and only 3. So let's do this little experiment here. If I do the probability of 0, so that's PDF 0, trial successes, and then I do 1, so that's 1 success, and then I do 2, that's 2 successes, and I do 3, which I already did. And I add all 3 of those together. So this again is the PDF. So I do this one plus 2. So I'm adding 3 plus 2 plus 1 plus 0. I'm adding them all together. Okay, I get this number 0.987. That's the number I get. Well, I could also do second distribution. So second vars to get to the distribution number. Scroll all the way down to the binomial CDF. And the number of trials is the same, 10. The probability was 10%, so 0.1. And I'm interested in 3. And I paste it. I get exactly that same number. Because what's happening is the binomial cumulative distribution function is adding up the success of 3, the success of 2, the successive 1, and the successive 0, and it's adding all of those together. So that's the difference between the PDF and the CDF. The PDF is at a single spot, and the CDF is at all of the spots, 0, 1, 2, 3, dot, 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 all the way up to the spot or the point of interest. The last thing I want to point out here is that the binomial PDF at 0 is the same as the binomial CDF at 0. Well, that's because you're just adding up the spot at 0. So in my calculator, if I did the binomial PDF of 0, I get this 0.34. And if I did the binomial CDF at 0, I get the same number. Okay, that's because this is only adding up that first spot. It's only adding up the PDF at 0 and nothing before it. So when I use the at least one formula, I tend to use this CDF. So I do 1 minus, and then I use the binomial CDF. So this would be at least 1, and I use the CDF because the CDF and the PDF at 0 are the same. But the CDF and PDF at some other value besides 0 are not the same. So don't be confused. You could use the same 1 minus, and then the PDF at 0. That is also the at least one formula, because remember, the CDF and the PDF are the same. So we get the same number.